Any local separation of the layers between the front glass and the encapsulant or the cell and the encapsulant, visible as bubbles or as bright, milky area. It may appear continuous or in spots. The position and size of the delamination or bubble depends on the origin and progress of the failure. The adhesion between the glass, encapsulant, active layers, and back layers can be compromised for many reasons. Typically, it is caused by the manufacturing process, like poor cross-linking of EVA, too short lamination times, too high pressure in the laminator, contaminations, improper cleaning of the glass, incompatibility of EVA with soldering flux, inadequate storage of the raw material, or environmental factors, like thermal stresses, external mechanical stresses, UV. Delamination is generally followed by moisture ingress and corrosion. It is therefore more frequent and severe under hot and humid conditions. Delamination or bubbles do not automatically pose a safety issue, but they can result in reduced insulation of the component and increased safety risk when they form a continuous path between electric circuit and the edge due to possible water ingress. Moisture in the module will decrease performance due to an increase of series resistance, affect long-term reliability, and in some cases also the structural integrity of the module. Moreover, delamination at interfaces in the optical path will result in additional optical reflection and subsequent decrease in current. This can be the origin of current mismatch. If the mismatch is significant, it will trigger the bypass diode and cause further power loss. The inverter might also shut down due to leakage currents, leading to a further performance loss. Manufacturing-related delamination issues often affects a relevant percentage of modules within the same production batch and consequently has a big impact on system performance. Any damage of the backsheet, surface or whole stack, that is visible as crack, burst or scratch. The location and extent of the cracks depend on the cause and progression of the failure. The cracked area may be localized, like bursted bubble, scratch, extend along specific module areas, like long or between the cells, along the bus bars, or extend over large or the full area of the module, like embrittled surface. The crack can be very deep and affect the backsheet stack. The degradation of the backsheet can be caused by environmental factors like UV radiation, thermal stress, external mechanical stress, or by internal stress, like thermomechanical stress with the multimaterial composite PV module, or incorrect handling during transport and installation, local cuts, scratches. Deep backsheet cracking, whole backsheet stack split, is often followed by moisture ingress and corrosion. This is more frequent and severe under hot and humid conditions. The use of low-quality material, like low UV resistance, or incompatible material combinations between backsheet to encapsulant causes most of the premature degradation failures. Discoloration and strong chalking can be precursors for backsheet cracking. Deep cracks or bursted bubbles can be the result of local hotspots, burn marks that split or break the backsheet. A broken backsheet can cause electrical insulation failure, posing a safety hazard and a potential ground fault. On the long term, power degradation due to the penetration of moisture into the module, which induces further failures, like corrosion, delamination, can occur. In the case of deep cracks reaching the active part of the cells, the insulation is immediately compromised and safety is not anymore fulfilled.